Okay, so I'm going to continue now on the second video. We just finished up finding domain and range of graphs, and we found a couple other pieces of information with that. But we're going to continue on the domain and range, but we're going to look at it uh, when we're given an equation. And this is a little bit more abstract. You know, up here you have pictures, and you can kind of rationalize it to yourself a little bit easier. But when you're given equations, it can be a little bit more challenging. So I give you a couple hints here. So first of all, we want to remember that domain are the possible x values that will be part of your graph. So if you look up here, see it was infinite because you could pick any x value, right? And but if you look here, we didn't have any negative x values over here, right? We only had positive x values. So remember, domain are the possible x values. Hint, try to find the restricted x values. So try to find the ones that actually you would not be able to plug into the equation. And so basically, you're going to look for values that are undefined or not real. Okay, so undefined are going to come up whenever you divide by zero. Dividing by zero is going to give you undefined. And then if you have a radical, a square, well, specifically a square root, if you're square rooting a negative value, it results in a non-real value. And we'll see some of those later on. Okay, so this first example right here, so basically you're just trying to look at this. If you don't see a fraction, if you don't see a fraction and you don't see a square root, then you should be fine. So the domain here is going to be from negative to positive infinity. There's nothing restricted here. You can plug in anything you want for x. Any negative, any positive number, you can plug in 0, and it doesn't come back as undefined or non-real. By the way, if you were to graph this, it would just be a line. It would look something like that if you were to graph it. Okay, number 3, we do have an issue here, and the issue is we do have a fraction. And so remember, you can't divide by 0. So what you want to do is figure out what would cause the denominator to equal 0. So we take that, set it equal to 0, and solve this. This should be fairly simple. We'll add 4 to both sides. So that value is actually going to be restricted. We cannot actually, someone put cannot, x cannot equal 4. That would give us, that'd be a problem. If you plug in 4, you get 3 divided by 0, which would be undefined. But if you plug in anything else, like 4.1 would be fine, because just as long as the denominator is not 0. So the way you're going to have to do this on your homework is they want interval notation. So you have everything from negative infinity all the way up to 4, but not including it, so we put a little parentheses there. And then union from 4, and we continue on to positive infinity. And that's your answer. And if you want a little visual of it on the number line, so here's where 4 would be. And so see, you have an open circle there, but then you're shaded in both directions right there. And so that's the first half right there. And then there's the second half of my number line right there. Just to kind of give you a little visual of that. Okay, number 5, I don't see a fraction. I don't see a square root, so I'm fine. The domain on this one's going to be from negative to positive infinity. And if you were to graph this, this is a parabola shape, so it would look like that. So it goes left and right indefinitely. Okay, so if you look at number 7, number 7 is a lot like the fraction we had on the other page, except that I need to factor that, and I'm actually going to have 2 excluded values. So remember, we don't want to let the denominator equal 0, so we're going to go ahead and figure out what would cause that to happen. So I'm going to factor this. This would factor into, let's see, x minus 5, x plus 3. And so the 2 restricted values, set these equal to 0 and solve. And so I don't have a lot of room. So I'm just going to put x cannot equal 5, because if you let it equal 5, it would cause it to equal 0. And then also x cannot equal negative 3. So kind of like what I did before, I'm going to give you a number line to kind of look at this, but our final answer needs to be in interval notation. So we're going to exclude -3 and we're going to exclude 5. So I'm putting open circles around them. But everything else is included. Everything else is included. So this first part right here, this would be from -infinity to -3. We got to do union. Got to use our union symbol. And then from -3 to 5. And then another union symbol from 5 to positive infinity. Okay? So this right here, this is how you're going to have to put your answer on the computer. So hopefully the visual can help you a little bit there. Okay, the next one, now we're dealing with the square root. And so this property I was telling you earlier is, well, let's kind of review square roots for a minute. So we should know the basics, like, square root of 4 equals 2, right? Well, what about square root of -4? We do have an answer for it, but that answer is non-real, and that's something we'll talk about a little bit more later. But it's non-real. Okay, it's not. A lot of times students, oh, it's 2 or it's -2. It's actually neither of those, and so I'm not really going to go in depth on that right now. But basically, you cannot square root. Well, you can. There's a different number system for it, but it's the complex number system, and they're known as non-real numbers, okay? So anyways, you can square root 0. 0 is fine. Square root of 0 is 0, okay? So what we're going to do here is this expression inside here, we don't ever want it to be negative. So what we're going to do is we're going to say, okay, well, x minus 3, that expression needs to stay greater than or equal to 0 because we don't want it to go negative, right? And so we'll go ahead and solve this. We'll add 3 to both sides. And we're going to get x is greater than or equal to 3. So that's my answer, but now I have to convert it to interval notation. But looking here, see, as long as I plug in 3 or something bigger, I'll never square root a negative number. So my domain is values from 3 to infinity. If I plug in any number between 3 and infinity, and this time I get to include 3, there will be no issues with that. Okay. So looking at 17, if you look at 19, they look very similar. I got the square root of x minus 3. The only difference is it's in the denominator spot. So the only difference that's going to make from what I had up here was that, remember, my expression just needed to be non-negative. Well, now I need it to be non-negative, and actually I can't let it be 0, because if it's 0, then I'll end up dividing by 0, and that would be off limits. So the only difference here is my expression actually needs to be larger than 0. If I plug in 3, I can square root it, that's fine. The only problem is then I have a 0 in the denominator spot. So that's why this time I use the greater than and not the greater than or equal to. On 17, it was okay. It's okay if the expression is 0, not a problem. Square root of 0 would be 0. But the problem here is I'd end up with 1 over 0, which would cause a problem. So that's why I only have the greater than symbol here. So we'll go ahead and add 3, add 3. So x just needs to be greater than, than 3. So the only difference on my solution set for my domain is that I'm going to use a parentheses with 3, which will indicate that it's not included. So everything above 3 to infinity, that's what the parentheses indicates. So not including 3, but anything more than that, and then to infinity will be fine. All right, so 23, pretty much like the one up above. You just want to take the expression 24 minus 2x, and then that expression needs to be greater than or equal to 0. Now I can put the equal back because I don't have a fraction. So we'll go ahead and solve this. Let's see, so I'm going to subtract 24 from both sides. So I got negative 2x is greater than or equal to negative 24. And then what we want to do here is when I divide by -2, be careful, you're going to have a sign change right there. You're going to have to reverse the inequality symbol. So we're going to get x is less than or equal to 12. And that's a property we covered in the last unit. Was if you multiply or divide by a negative, you have to reverse the inequality. And then now we just need to put the interval for this. So x is going to be all the values less than or equal to 12. So from -infinity to 12, and we do get to include 12. There we are. Okay, I got 2 left here. Okay, so what you'll notice on 25 is I got two square roots going on here, okay? And whatever set we end up with, we have to make sure that we don't square root a negative at any time. So let's look at each one individually. So this first one, x minus 2 needs to be greater than or equal to 0. We have x plus 3 needs to be greater than or equal to 0. And so we'll solve both of those. So the first one, let's see, x is greater than or equal to 2. And then on this other one, I get x is greater than or equal to -3. So now it's like, okay, well, which one is it? And yeah, one of them's correct and one of them's incorrect. And so I will try to give you a little visual with this. Let's see. So I'm going to draw 2 number lines here. All right, so the first one is at 2. And that would be our interval right there from 2 to infinity. And then our other one's saying, no, what about -3? Could we start back here at -3 and go from -3 to infinity? Okay, so one of these is correct and one of them's incorrect. And the one that's going to be correct is where we have the overlap, where there's protection for both intervals. And that's going to be this part right here. It's going to be from 2 to infinity. And so that is our interval for our domain right there. And the reason why is if you pick something in the blue set, it won't be good enough for my other radical. So for example, if I were to pick like 0, if I plug in 0, there's going to be a problem right away right here. I'm going to end up square rooting -2, which is non-real. That would be a problem. If I plug in 0 here, it's okay. But the problem is, whatever I plug in, it needs to work for all parts of your equation. If it only works for part of it, and somewhere else you're getting a non-real result, then that's going to be a problem. And so what you want to do is just find the overlap, and that's the interval you want to use. All right, last one. So I got 2 things going on here. I've got a fraction and I have a square root on top. Let's look at the fraction on bottom, the denominator first. That part should be pretty easy. So we know that x minus 5, we don't want that to equal 0, right? We don't want to divide by 0. So we'll solve this real quick. So x cannot equal +5. So we know that. X cannot equal +5. Okay? But there's also some other restricted values that are not 5 that I can't plug in. Because like if I plug in 0, that would be a problem because the denominator would be okay, but I'd be square rooting a negative number. So let's look at the inequalities separately. So our inequalities, we only want to evaluate those at positive numbers. So it needs to be greater than, or I'm sorry, non-negative. Because we want to include 0. So x minus 2 needs to be greater than or equal to 0. Okay? It's not in the denominator of a fraction, so you don't have to worry about 0. 0 is okay. So we're going to go ahead and add 2 to both sides. And so we get x is greater than or equal to 2. So I have 2 conditions. I have a condition saying x needs to be greater than or equal to 2, but we're also saying x can't equal 5. And so those are going to have to come together. And so I think doing the number line will probably make this a little bit easier. So I'm going to go ahead and put a 2 here and a 5 here. I know 5 is off limits, so I'm putting an open circle right there. Now 2 is okay. 2 would be okay. Okay. Everything leading up to 5 and then everything after 5 would be okay. Okay, so let me go ahead and write the interval out, and we can talk about that little, why we got to exclude the 5. So my interval would be from 2 to 5, not including 5, union from 5 to infinity. And that is my answer right there. So we have to exclude the 5, even though the 5 would be okay for the numerator. If I plug in 5, it'd be okay for the numerator, but the problem is the denominator would end up equaling 0. Don't want to divide by 0, can't divide by 0. Dividing by 0 is undefined. So if you plug in 5, sure, you could square root 3, 5 take away 2 is 3, square root of 3, but then you would be dividing that by a 0, and so that's why we need to cut that out. Okay, so this part of our unit is a little abstract, okay? So it takes a little bit of time for it to kind of really sink in. So don't get discouraged, work on this, take a break, work on it some more. It's just going to take a little bit of time, okay?